and gentlemen, thank you very much. We shall start this session. So I have the honour of being the chairman for this afternoon's session on mega project investment. My name's Piers Clark, and I'm a partner at the new private equity fund that's been established by Blackstone to invest in water, called Global Water Development Partners. Now, we've got three presentations this afternoon. The way I propose we do this is we'll do each of the presenters will stand up, tell their story, and then we'll save questions until the end, and we'll have all three panelists come together at the end and do questions from the floor there. As well, I think we should play this. And if I can ask the presenters to stand up, and when you, at the start of your presentation, say a little bit about your background and who you are and what you do, so that for the benefit of the wider audience. I will sit there rather than here so that I can see the slides and enjoy the presentation. But if I start waving at you frantically, it'll be because you're running out of time. So I'll give you a 5-minute warning and we'll play it from there. So, look, I'm glancing across at the three presenters. I think everyone's happy with that. So if I'd like to invite our first speaker up, which is Engineer Nasser Al-Nuaimi. If you'd like to come up, please.
Thank you. Thank you very much. I'm Nasser Al-Nuaimi. I'm Deputy Program Manager working in IWS in the STEP projects. Well, my background, I worked in different fields. I work in oil fields. I work in power and desalination plants. And finally, I'm working here as a project manager. Today I'm going to talk about one of the mega projects that's been done or managed by IWS, which is really enhancing the infrastructure of Abu Dhabi, island and mainland. My presentation is the program overview, the STEP concepts, and I'll talk about the progress work and where are we in with this tunnel. Sorry. So the program overview is Abu Dhabi transformed from Berling Center to a global business powerhouse. You will see in this slide Abu Dhabi developments for the last 60 years. So this picture shows Abu Dhabi in 1950s. This is the Corniche area, and you see all these small houses. With the development in 1960, this is the new other pictures of 1960s. And here we see that the Corniche start to, to be constructed. That's in 1970s. And we see tall buildings next to Corniche in 1980s. And as you move forward, you see a lot of developments and a lot of growth in Abu Dhabi, which you really need to improve your infrastructure regarding waters, sewage waters, power, everything. So this is 1990s. This is the capital and the Corniche area in today, actually. Sorry. This one and this one today, Corniche. And this is the conceptual study that we have for Zayed capital, or the new capital, I would say. This is just next to the airport. So you see the developments and what really we need to improve in Abu Dhabi. As part of Abu Dhabi government, IWS take care of the sewage, transferring the sewage to the treatment plant and treat the sewage and send it somewhere. So you see in 1975 we have the Ministry of Public Works, which really take care of that business. Then in 1975 itself, there were two parts. In Al Ain parts, there was a drainage network company, and in Abu Dhabi Sewage Project Committee, the SPC. In 2005, the SPC and DID, those two companies in Al Ain and Abu Dhabi merged together and become one company called ADSSC, Abu Dhabi Sewerage Service Company, in 2005. And 2008, sorry, the mega project thinking start, and the program of STEP has started. Early 2009, ADSSC was established, was really an own company, I would say, of a unit company. The ADSSC visions to be recognized by committees, business, and regulation as a world leader in provisions of sewage by 2020. And the mission, as you see, to achieve the excellence of provision of high quality, cost-effective, and safe environmentally compliant sewage services in the Emirates of Abu Dhabi. See, this is really the core business of us. As you see that we collect the sewage from different places, from industry area, from residence area, from commercial area, and in main trunks and main sewage pipes, and send it to the pump treatment plant and just to treat it. And then these treated water get used for landscapings and the green areas. The total network up to date is around 8,000 kilometers all around Emirates of Abu Dhabi, with more than 298 pumping stations taking care of this business. Abu Dhabi sustainable used water. This is the solution. This is the step. As you see here, it's a sketch or a drawing, picture of really what is the step. It's a sustainable design that allows gravity to do the work. So you really avoid using electricity and avoid using power and the maintenance. Returning the used water to improve the living environment of Abu Dhabi. So you see the blue trunk here. This one, this is the main tunnel. You'll see in more picture, more details later on. And here's the collection. This is the network to represent the networks where we collect all the sewage and just put it in the water. And this is the pumping stations that we're building now in STEP. And pump all the sewage that's coming from Abu Dhabi Island and mainland to the treatment plant existing in the Wathba area. So STEP, if you go around Abu Dhabi, you may see the signs of STEP, but really it's just a sign of a place of the manhole that we work in or we're using to lower the machines or lower the manpower or the plants to use it. So really it's invisible surface where you will see later on the visible surface with the green area and improve Abu Dhabi. I take this word from late Sheikh Zayed. Really, it's really a word that I always remember. I will read it really word by word. What he's saying here that we cherish our environment because it is an integral part of our country, our history and our heritage, on land and in the sea. Our forefathers lived and survived in this environment because they were able to do so. Only they recognized the need of conserve this environment, to take from it only whatever they needed and whatever they needed to live, and to preserve it for succeeding generations. So I really take this word and really look at it as ADSSC and as employee. So partly, this is the STEP concepts. Why STEP? Why STEP? Due to the aging of the existing surfaces, the capacity limits that we have, we over capacity. And the future development that's in Abu Dhabi is happening, the booming, the economical booming, all the building industry. And the time constraints, really, we need to look for really a fast method that we relieve Abu Dhabi and improve the infrastructure in Abu Dhabi. And we want to protect really the image of Abu Dhabi. And the removing, I don't know why the photo should be the other way, but anyway, it's removing the existing pump station will really help us to use this lands, some other business like green lands or landscaping or something. So the STEP benefits you will see here in the green table. Now the gravity will meet the Abu Dhabi Visions 2030. Really, this is our aim. The significant reduction, really the cost, currently the cost of operation and maintenance for these pump stations, the 34 pump stations that you'll see later, it's more than 100 million a year, 100 million dirhams a year. So really this will have a mid-term and long-term solutions for Abu Dhabi, and the gravitation existing pump station allowing creation of new land, as I mentioned, for this 34 locations, especially it's in residence area, as you will see in the next slides, which will show, sorry, the next slide, which really can use it. So this is the program. The owner is Abu Dhabi, so we're representing the government of Abu Dhabi. So the owner is Abu Dhabi Sewerage Service Company. The program is, we call it STEP, Strategic Tunnel Enhancement Program. Started from the beginning in 2008. Actually, the idea was earlier than that, but really the brainstorming, putting things in papers, started in 2008, and it's still ongoing, and hopefully will finish by end of 2015. The cost is 5.6 billion dirhams, around 2 billion. So it's contained three major parts, but I'll talk about it in next slides. The highlights is just the main one. I would say that the capacity of this steps is 1.7 million cubic meter per day. So this we're talking about 2030, the year 2030, and the population of I would say between 6 to 8 million population. So you'll see this is the map. The red color, the red line, this is the tunnel. It's starting from Mishrif area in the middle of island and ending at Al-Wathba area, 41 kilometers with a diameter starting at 4 meters and ending at 5.5 meters. The depth starts at 24 meters and we finish here 90 meters. And this is the main, this is the tunnel. The yellow line represents the networks, or the link sewers, I would call it, which will link the existing, this blue triangle, the existing pumping stations to the main tunnels. So you see we have around 22 pump stations in the island, and we have 12 pump stations in the mainland. This blue line, the one I'm talking about, that can be replaced for landscape, green yards, playground for the kids. Especially, it's really in the middle of the residential area. The last part is building the deepest lifting station in the world, which is 100 meters below here in Wathba area, where this one with a capacity of 1.7 million cubic meter per day. As you'll see in details, really, I'll show in details the excavation and the depth, the activities, and how far are we in the program. This pump stations, as I said, its capacity 1.7 million cubic meter per day is the last part, and it will take all the sewage that coming from Abu Dhabi Island and the mainland to the treatment, the existing treatment plant at Al-Wathba. So the progress. This is the tunnel. This is actually the show a sectional view of the geological of Abu Dhabi. Most of the soil that, or what you call it, the soil that faced in the tunnel boring machines that we use is mudstone and gypsum. So you see along the line, and we finish 100% of the tunnel, the 140 kilometers, and I'll show you the photo of really what you're going to see in the top. I mean, after we finish the tunnel, really what you will see in the surface. And this is the link sewers. All the green lines that we finish. We've, as I said, in the total, it's 45 kilometers. We finish around 38 kilometers out of 45 kilometers. We finished 38 kilometers from the link sewers. So you see, we work really in congested area. This is just in front of Khaldiya Mall. This line here, in front of Khaldiya, this line here is in front of Khaldiya Mall. Here behind Spinis, next to the Corniche area. So we're almost there. This is another picture of the link sewers. It's LS1. We finished 44%, 44%, and LS2, which is the mainland, we finished 67%. So this is the tunnel. You see, the tunnel is this is one of the sections that we have. We have different colors. If you see the early picture, this one represents different colors. So this picture is taken in this white area. So as a progress, I would say that we're okay, we're fine, we're almost there to meet the target of 2015, December 2015, to run, put the sewage in the tunnel. This is the manhole. I should have a photo, actually. I have it in my flash memory. If someone wants to see it after the presentation, really the progress of work, how far are we? This manhole, the lid is 1.5 meters, the diameter. Actually, this place itself, it was 18 meters. The diameter during the construction work, it was 18 meters. This is used to lower all the TBM machines, the tunnel boring machine, and all the services and the employee and the plants, whatever we need. So really, you cannot recognize where is the step now. Now the pumping station. We have 50 minutes. So the pump station will be the only existing service after the tunnel. I'll show you the different buildings. So the pumping station, as you see here, the flow will come from the tunnel here, will be pumped by 8 huge pumps. We're going to, it's already inside, and pump it to the distribution chamber here, and give it to the treatment plant. So over 1.5 meters, I said, of depth, and 50 meters wide, and ultimate capacity of 38 cubic meter per second. We're going to use 10 pumps, each of 6.0 motors. Actually, in the beginning, we're going to use only 8 pumps, but there is a future expansion if we need another 2. We have 2 big generators, which in case that the main power supply, a blackout or something, we have a standby diesel generator which can run the pump as to the capacity. I would show this image. You will see really the scale of man comparing to the pump station, human. Right. So the pumping station is as deep as 30 stories below ground. So this is the man. See? And here it shows the pump. Actually, this is just a schematic drawing. So this is the motors. The pump is here. This is what you'll see later. Really the progress I will show you. I've been asked actually by the summit people that to show really the progress and show the pump station developments. And how far are we? Really, are we going to meet the schedule in 2015 or not? So you'll see really the next slides just going very fast, but bear with me that it will just build itself. You'll see the green area, concentrate in the green area, that this is the developments that's going to happen. But after 2 slides from her. So this is the location. This is the shaft, the big shaft, 50 meter wide. This is different buildings here. And this is actually the switch gear room and the VFD. This is the odor area here. And this is the TSC water. Okay. See, this is work shaft 9, the last point in the tunnel, as you see in the line. This is work shaft 9 during the early stage. This is the 50 meters before we start. We're just starting. This is the pump station. This manhole here. So this one, the distance between the tunnel and actually, the last point in the tunnel and the pump stations. I hope I have a picture that shows the shaft. This is just a construction. See, this is taken in last November. Shaft, toe beams, and upper wall. You'll see this is insulation and this is the base slab. So the sewage will come this direction, will come from here. So this is the tunnel coming from here. And the elevator will be in the middle. Now we're using the elevators, actually mobile elevators and cranes actually, to lower the people. You imagine how many people are working now. I really count those people, more than 50 people are working same time. This is the tunnel. You see this one? This is the tunnel, and this is where the flow of sewage will come, the inlet chamber. And this is the wall. Now, if I press OK, you will see the green area. This is considered like really the development or the progress of work. And slide after slide, you'll just, I try to control it, but the last moment, but it was difficult to control, to show you slide by slide. But really, and you'll see the dates here. This is actually December 2014. This is the status of December 2014. But with the day, you'll see until December 2015, which is the commissioning day, hopefully this year. So just concentrate on this date and the green development, the green color. See, the wall here is coming up. Now the elevator is coming up. This is the wet well here, this side. And October 2015, November 2015. And now the sewage will come. And that's it. I think hopefully we'll meet the schedule of 2015. Really, we're working on it, and we are with the contractor and the consultant to meet that date. And that's it. Thank you.
So thank you very much for that, and thank you for being so slick. It's buying us time, and actually, I'm still going to switch. I think we're doing all the presentations, and then we'll do questions at the end, if that's okay. So our next speaker, which I get these in the right order, is Engineer Malcolm Haddock, also from the ADSSC. Malcolm, all yours.
Thank you, thank you. Good afternoon, everybody. It's very good to be here again to talk about recycled water. I have a lot of slides, so I'm very happy that my colleague Nasser was a little bit quicker than he planned. So I have around 70 slides to get through. Yeah, well, we'll see. I'm not moving until I'm finished. So some of the slides I will go through quite quickly, but I just want to give everyone here an overview of the picture with recycled water, and to have a look at where we're using it just now and where we could use it in the future, and which projects could be feasible and which projects should we think about doing, which would help use up all of the recycled water that we produce. Welcome, ladies. So I'm going to give an overview. I'm going to take a look at the city infrastructure schemes that could happen, some of the regional schemes slightly outside of Abu Dhabi that could happen, and they're mainly towards Dubai, towards Al Ain, and possibly also in the Western region. I'm going to take a look. Good afternoon, Mr. Matthew. You're late. Well, actually you're early, but that's okay. Have a look at the MPV cost per cubic meter of water applied. Have a quick look at the policy and strategy from the various entities in Abu Dhabi, and also an attempt to look at the way ahead with what we should do with the recycled water. Here we have a map which shows the location of all of our treatment plants in the Emirate. The big ones are Mafraq, Wafa 1 and 2, Al Saad and Al Hama in Al Ain. We have some smaller, medium-sized ones in Madinat Zaid, Liwa. There's a new one getting constructed in Beira Mataba right now, a new one going on in Ruwais right now, and we have a large number of smaller plants in the Al Ain remote areas, and quite a number of them around the city also, for Sadia, Yas Island, Masdar, etc. All of these treatment plants are producing very high quality water to the standards laid down in the 2010 residuals regulations laid out by the RSB, the Regulation and Supervision Bureau. So right now we are using not all of the water. You can see this table. I really wish I had rounded those up. I don't want to go on too quickly. For Abu Dhabi, we're producing right now, as of August last year, 616,000 cubic meters per day. Alain, 195,000. Western region, a very small quantity in relation to the others. In total, around 850,000 cubic meters per day. You can see here, this graph shows us what is used and where. We can see, although the bottom axis has been cut off a little bit, and this thing keeps going ahead of me. Abu Dhabi, we are wasting a lot of water. We're not using all the water, which is very unfortunate in my opinion, and we really should be looking at maximizing, fully reusing all of this wonderful high-quality resource. In Alain, we have a success story. Almost all of our recycled water is being used in Alain through mainly municipal irrigation. In the Western region, the quantities are very, very small, and so there is still a small quantity of water which is wasted. However, it doesn't give us such a big headache compared with Abu Dhabi City. And I've got another one here. There's pie charts, so giving you tables, giving you graphs, giving you pie charts. And here is, there you go. That's just, they're not to scale, so don't read too much into them. But you can see that we are wasting almost 350,000 cubic meters of recycled water every day, which is quite a large quantity of water. I'm sure you'll all agree. This graph here is an old graph. Dr. Dawood will be familiar with this one. It's looking at the demands of irrigation, landscaping, farms and forestry around the central region, which is the Abu Dhabi City area, with district cooling in there also from developers, from Tabreed, from other entities. And the brown line, or the orange-brown line, you can see our water production here in the city. So although the production will increase over the long term, it's still nowhere near enough to satisfy the theoretical demand from developers, from PRFD, the Public Recreation and Facilities Department in the municipality. So demand outstrips supply, but as I've showed you before, we're dumping water. So how can that be? If we look here, these flows, this graph shows 2012 end user flows. The blue section is the water which is discharged to the ocean. The small colors in the middle are smaller consumers like Al Fawzan, Abu Dhabi National Golf Course, and other smaller customers. The green block is from the municipality here in Abu Dhabi, which is the Public Recreation and Facilities Department. So you can see their use throughout the year is quite constant. It decreases in December and January and February because obviously the cooler weather, and it increases slightly in the summer with the hotter weather. Here we have a graph showing 2003, so you can see that this is the difference between 2012 and 2003. There isn't very much difference. And if you look at 2004, same again. It's not a great, there's not a great difference. We're not really seeing an increase in the consumption of recycled water for the city irrigation over the last 3 years. And I'm missing the figures for December there, forgive me for that. So really, the next few slides is just some words which will give you some description of the background. Around 850,000 cubic meters per day in the whole emirate. The recycled water that we produce is only 6% of the entire Abu Dhabi water cycle. The much bigger parts of the water cycle are groundwater and potable water. It's a very high quality recycled water. It goes through, our sewage goes through primary, secondary and tertiary treatment with chlorination after sand filtration in almost every one of our treatment plants. And we actually have a lot of nutrients still in the water, which I will talk about a little bit more. In Alain, well, the law changed in 2009 that allows us to supply it to other third parties other than the municipalities. This resulted in a huge number of requests for our recycled water to come from developers such as Bunya, Aldar, UPC, other entities looking to irrigate their mega developments. All the water in Alain is reused, so in Alain we need to maybe be more efficient with the reuse and try to spread it further and spread it thinner so that more people can use the water. The western region produces relatively small quantities, but we still need to do something to use up the spare water in there. We looked at aquifer recharge, and the problems with aquifer recharge is that the aquifers which are suitable for recharge are far away from the recycled water production plants. In Abu Dhabi, the ground conditions are not suitable for recharge. In Alain, we don't have any recycled water because it's all being used. In the western region, where we could do aquifer recharge, the quantities are very small. So geography and geology is working against us in that situation. We're discharging the recycled water to the Gulf at a location in the Masafa Channel, near the Masafa industrial area. Back when we built the first big treatment plant, Mafraq, and our subsequent other big plants, WAPA 1 and WAPA 2, there was a specific decision made at that time to keep nutrients in the water because we knew we wanted to use the water for landscape irrigation. So phosphates, nitrates, and nutrients like that stay in the recycled water, which benefits the plants, benefits the vegetation, and is very good for the overall greening of the city. However, when we discharge water to the sea, those very same nutrients are extremely bad for the marine environment. So the decision that we made to keep the nutrients in was good for landscape irrigation, but very bad for marine discharge. So this is one of the, probably the biggest negative effect that we're having from discharging water to the Masafa Channel. We own and maintain only the transmission infrastructure. You will see a drawing very soon, and I'm going to focus on Abu Dhabi City here because this is where we're dumping the water. We are not an end user, so our responsibility is to transmit bulk quantities to reservoir locations from which downstream other entities are responsible for the distribution and application of the water to the various irrigation areas. And I think some of the downstream infrastructure in many areas isn't big enough to take all of the water. So although you will see in the city we still have some areas which are not yet irrigated, some areas the distribution infrastructure cannot get our water to those areas. The demand is extremely high, theoretical demand. We as a company, I noticed that we had insufficient infrastructure to convey the bulk quantities to some of the locations, and we initiated a project which I will show you in some following slides, which invested almost 1 billion dirhams into a large ring main which would feed large quantities of water to strategic areas around the city, mainly to feed developers and PRFD demand. That infrastructure investment which has taken place, we still haven't seen the downstream infrastructure being developed and investment taking place. So around the ring main, we're still seeing areas that haven't yet been irrigated. One interesting thing is that UPC policy is to reduce landscaped areas. So to remove some medians along the roads, to cut down in landscaped areas, to introduce xeriscaping to the area, which will actually reduce the consumption of recycled water, which if it happened right now on a large scale, would result in more water going to the Gulf, which I'm sure everyone would accept is not a difficult situation, not an acceptable situation. So we have looked at expanding our transmission infrastructure further in the city and surrounding the city in order to feed large quantities of water to a number of areas that would allow us to eventually get to 100% reuse. And I'm going to take you through some of the projects now. With this one here, You can see the red lines are our existing pipes, the ring main surrounding Capital District, and the spur going up to all the way up to Yas Island, and also onto the main island. That red line doesn't actually go through the creek as it's shown there. I think something's happened to my PowerPoint presentation, so that's not very accurate. However, you can see the green lines on the drawing are the infrastructure owned and operated by others, and the blue lines are construction projects which are happening right now to Al Falah development and to Gaf Al Bohiran Forest down in the bottom right of the slide there. I apologize for that inaccuracy. We'll see here the areas which are currently irrigated, 166,000 coming from Mafraq, and the 200 and 235,000 coming from the WAPA plants. There's the overall balance at the moment. Almost 80,000 is coming onto the island, and around a total supply of 180 is coming from the WAPA plants, and the surplus is almost 350,000. Now, I hope these next slides are not too dodgy. Okay, so these are the areas which we think can be supplied by the ring main and the spur going up to Yas Island and Al Falah and to Gaf Al Bohiran. I'm going to go through these next slides quite quickly. I'm now at 50 minutes left. I'm watching that, Peter. Project number 1 would be an expansion of the transmission system up towards Lulu Island, Mina Zayed, and to Reem Island. Reem Island are screaming for water. They want to use it for district cooling. They want to use it for landscape irrigation. It's also where our offices are, so that would be nice to irrigate that area. The project would cost around 164 million. We would need to upgrade IPS 3A reservoirs and make some crossings across to Reem Island. The next project, project number 2, would be an extension up towards Samha. We're actually looking into doing that right now, and we have tendered the project, and we are waiting for final approval to award a project that will convey some serious quantity, around 140,000, up towards the Dubai direction. Project number 3 is the transfer of assets and rehabilitation of the central irrigation pumping station. 45 million, it would take 2 years to do. Project number 4, I think, is in there. Or have I missed project number 4? Project number 4 is the expansion of the system up towards South Shamka and to North Wapa public housing. Very large housing areas being developed as we speak at the moment by Musanada. It will take almost 65,000 cubic meters per day, or 55,000 I can see. 223 million. So you can see here we've looked at expanding the city infrastructure, and this interesting one here would be the conversion. We have 2 pipelines at the moment. Once NASA's project is finished, we will be able to decommission 2 very strategically important pipelines that are currently used to pump all the island sewage off the island to the mainland. This project will allow us to reverse the flow in those pipes and use those 2 pipes to convey recycled water back onto the island. Instead of pumping sewage off, we'll take recycled water back onto the island. Project number 6 is a similar situation up near the Spinneys area, a reversal of a pumping main, a sewage pumping main, to allow recycled water to come back on to that area. And another one which is just a transfer of ownership of IPS 11A, etc., etc. So I'm going to take you through the rest of these, and these can all happen, not all at the same time, but obviously as the demand is there, we could investigate how we would do these in a prioritized fashion if we were to seek funding from the government. And so on. We're looking at South Hadira, and we're looking at all of the city areas in order to get the whole place irrigated. If we were to do all of those projects in a long period of time, so over the next 10, 15 years, this is the area that we think we could irrigate with recycled water. If we were to apply UPC principles and policy with a view to restricting use, maybe we could even spread the water to a bigger area by using less in some of those areas. So you can see here, if you look at the NPV cost of the city schemes, a 15-year cost, a 30-year cost, and a 50-year cost, including all of the capital replacement costs, operational costs, and the initial capital investment. You can see here from projects 1 to 13, they are all below 1 dirham per cubic meter of water applied. You can see, I think it's projects 7 and 8 are the cheapest. Projects 1 is the most expensive. I forget which one that was, and that's the Al Reem Island one. And what I've done, I've got this graph and I've prepared the same costs for other regional schemes. But I'll show you this graph again later, but you can see the costs are relatively low. This is mainly because our recycled water system on the island is run by gravity. The big pumping station will pump the flow up to the treatment plants, and the recycled water will gravitate back to the city by natural gravity. So it's very cheap. It's a good system, it works, and we like it. The regional expansion schemes, I'm sure some will have seen before. This is the project that we're hoping to actually award very soon. It's the all the way up to Al Jurf Forest on the way to Dubai. These are the demands which we are going to cater to. So we've already designed this scheme, and it's with the Executive Council for final award. However, they're considering it amongst other initiatives with recycled water as to whether it will go ahead or not. However, we've looked at supplying this water to agriculture, forestry areas, and also to farms, agriculture, and some landscaping. Right now, this whole area is using potable water from ADDC. So this is actual consumption taking place right now. So if we were to do this scheme, it means we could replace a lot of potable water consumption with recycled water consumption. This is schemes going down towards the western region. The first one is Al Reem Island. The demand is very small, to only 10,000 cubic meters per day. The cost would be 164 million. If you see here, there you go, these blue and white dotted lines, these are lines of groundwater which are feeding these areas of existing consumption from the Liwa wells. So if you can imagine where Liwa is on the way down, away off the slide, those white and blue pipelines are feeding groundwater to these areas. That project would take 52 kilometers of pipeline, around 164 million. Similarly, if we go to I can never pronounce this one, Al Dabeya Island, the demand is only 20,000, still replacing groundwater consumption. This would cost 218 million. And if we went all the way down to Abu al-Abayad Island, this would cost 341 million dirhams, and have the demand down there, which is around 45,000 cubic meters per day, which will replace groundwater consumption. A combined scheme would cost 523 million, feeding all of those areas a much larger pipeline. Now, here is the Al Khatim scheme, which is going towards Al Ain, up the Al Ain trunk road. This would provide water to Baldiba pumping station, a new pumping station, and feed the areas which are currently using groundwater for irrigation. So this scheme would be replacing other groundwater consumption, which is happening right now. And this next one is the same scheme. However, it would be sized to be able to be expanded to the right, to the purple area. The next one, that's 760 million. This would be the full project altogether, 1.2 billion, but feeding the blue and the purple areas also. We have another set of options for this one, which would be to feed another couple of organic farms, which are being discussed at the moment with the higher authorities. Their demand would be approximately an extra 100,000 cube per day. So that scheme again would be revised and it would cost 840 million. And the next one would be 1.4 billion if we were to feed all of that demand in that area with recycled water. Now, if we were to look at the graphs of NPV cost per cubic meter, on the same scale of graph, you can see here that the Western region schemes are very expensive per cubic meter of water applied. The Dubai scheme is the cheapest. The Al Khatim schemes are in between. So you can see here the small demands of the Western region schemes and make the cost per cubic meter very high. So you can see here the regional schemes are very expensive compared to the city schemes, mainly because we're having to pump the water uphill to Al Ain, pump the water to Dubai, pump the water big distances to the Western region. So it's very expensive to feed water to these regional schemes. These are the two graphs again. I'll just show you them. So you can see here what's telling us and where we should maybe think about spending our money. And it might be the Dubai scheme, and it might be some of the city schemes. Now, with policy and strategy alignment, I'm down to my last 5 minutes here, so I'm going to, I might speed up here a little bit. The policy and strategy is something which I've been thinking about for the last 7 years with ADSSC. And the question is always out there, should we reduce potable water consumption? Should we replace groundwater? Should we spend the water on irrigation or landscaping? Do we get hold of all of the infrastructure which is with other entities at the moment under the regulation umbrella to try and help accelerate the development of those assets? Here we have an extract from the Environment Agency strategy, which shows that the target for full reuse of recycled water is by or during 2018. This is the strategy document which came out in 2013, I believe. But here we have the UPC, Urban Plan Capital 2030. They're telling us to have 50% reuse by 2025, 70% use by 2030. So this is giving us some confusion in terms of what we need to do as an entity who's responsible for conveying the large quantities of water to the various locations of demand. The three TAPs, potable, groundwater and recycled water, are managed by different entities. We have the main stakeholders, the EAD, the RSB, ADWIA, as it says there on the second bullet, are all very, very relevant and effective stakeholders. We haven't yet identified how much is irrigation and having green areas worth to us in monetary terms or in other metrics. We haven't yet established what the value is of saving the groundwater in terms of financial or another metric measurement. We haven't yet tried to quantify the intangible benefits of stopping recycled water going to the Masafa Channel. So really what is required is an integrated approach that may allow one single authority to make the decisions on which water to use where and when and how much money to spend in those projects. So this is a quick summary of what I think we need to do to push us towards full reuse. In Al Ain, all the water is used, so there's not much we need to do up there except to become more efficient with the water that we're currently using. The Western region, the quantities of water generated at the sewage treatment plants are very small, but we still need to put some small localized schemes in place. City irrigation demand is small compared to potable water and groundwater consumption along the Dubai Road and Al Ain truck roads. However, the Western region schemes are very expensive to push the water all the way down there. The city irrigation schemes would be relatively inexpensive to do, but the demand doesn't seem to be turning into actual consumption in the short term. We've already built the ring main, no one's using the water. If we were to expand further transmission schemes in the city, it's not likely the development would be there to use the water immediately. So really, and this has been looked at the moment, the recycled water assets, distribution and transmission, should be owned and managed by a single entity under a clear regulatory framework. This is being discussed at the moment by a technical committee set up by the higher authorities, and it involves the RSB, ADDC, PRFD, the EAD, and ADSSC. We need to really try to monetize or get numbers surrounding the intangible benefits of stopping groundwater use, replacing potable water use, and understanding the real benefits of doing that and not putting the water into the channel. The targets for full reuse are now becoming very, very difficult to achieve if we're to look at the Environment Agency strategy. Therefore, it's looking like the discharge to the Masafa Channel will continue until such time as we make investment decisions for large-scale transmission schemes. And also, more importantly, I believe, downstream infrastructure is invested in also. We really need to push ahead with the Dubai scheme. This will use up 140,000 cubic meters per day. We really need to push ahead with the Al Ain truck road scheme. That will use an even larger quantity of water. The remaining surplus could be then used to be efficient with some smaller city schemes as and when the demand is actually realized, and we can also consider district cooling and other industry practices such as Emirates Steel and TACA energy to waste plant down in the ICAD area. And now I'm on 15 seconds left of my 30 minutes, and I'm finished. Thank you very much.
Malcolm, thank you very much for that. I honestly, when you said the number of slides you got, I thought there is no way on earth we're going to finish in time, and to land so perfectly is terrific. Thank you. So our last speaker in today's session, yes, I'm in the right page, that's good. Our last speaker in today's session before we move to the question and answers session is Dr. Mohammed Dawood, who's going to talk about the redistribution and reuse of TSC water in farming and forestry. Thank you.
Thanks, Mr. Chairman. Good afternoon, everybody. Actually, Malcolm makes my presentation a little bit more easier, so I will cover the points which have not been covered by Malcolm, and then we can continue. As mentioned by Malcolm and the other people now, we are producing about 1.2 billion cubic meter of desalination. Only about 20–25% is returned to the sewerage system, and this is also defendable because most of this water are used for irrigation, either in agriculture sector and sometimes in forestry sector, amenity plantation, landscaping and recreational areas, or even for the domestic sector for the outdoor use. So the return value is about 285 million cubic meter a year to the sewerage system, which is tertiary treated, and out of them about 40% is used and 60% are not utilized at present, as have been mentioned by Malcolm in more details. If we look to the whole water cycle in Abu Dhabi Emirate, we will find that the treated wastewater is contributing by about only 6 to 7% out of the total water balance for Abu Dhabi Emirate. However, the groundwater is contributing with 63% at the most recent statistics, and 24% by desalination, and the remaining, which is 7% by recycled water. It seems that it's very minor quantity compared to the whole water balance, but it is more effective than other because it contains more nutrients, it's more cheaper sometimes than pumping groundwater, and desalinated water is more costly and more environmental friendly source to be used, especially in agriculture, landscaping, amenity plantation, forests, and other purposes. As mentioned by Malcolm, we do have about 33 desalinations. We have 33 desalination treatment plants, produced about 284 million cubic meter a year of tertiary treated wastewater. Out of them, we have 4 biggers, 2 of them in Al Ain, which most of the produced water is fully utilized at present, and we have only 2, Al Mafraq and Wasban and Wasbat 2 in Abu Dhabi Island, or near Abu Dhabi Island. Out of them, about 45% of their production is not utilized at present, so we are looking to reuse this quantity of water. So the reuse is 46% and the non-use is 55%. Most of this water, unfortunately, is discharged to South al-Musaffah area, which we do have a lot of environmental problem because it is very narrow channel, very shallow in terms of depth. The depth is something like 4 or 5 meter depth, and we have a lot of here industrial areas, ICAD 2, ICAD 3, and a lot of industrial areas, and the water here is very dirty. It's including a lot of nutrients, and now we did a new or a recent hydrodynamic modeling and water quality model for this area, and we found that the problem that this is bloom started to increase here in this area also, and affects the desalination plants in and Nar. And this is expected to affect our desalination plants production in the future if it's continue and we don't find a mitigation measure to overcome this problem and to utilize this tertiary treated wastewater. At present, as I mentioned by Malcolm and by Nasser, most of this water is used for landscaping, recreational areas in Abu Dhabi Island and outside the Abu Dhabi Island. But also regarding to our expectation, because our calculation indicating that the annual increase or the average annual increase in the produced treated wastewater is between 8 to 10%. So with this increase by 2030, we'll have 1.4 billion cubic meter of treated wastewater, or if we continue producing the same, or if it's not more even. So we have a lot of drivers to go to the reuse of treated wastewater. The first one is the scarcity. We are an arid region. We don't have enough water. Our groundwater is depleted and it's over-abstracted because of the extension in the agriculture sector and the forestry sector. So we are bumping 20 folds of the nature recharge to the aquifer system. The water drop in some areas is 5 meters every year. The deterioration in the quality, it's very now, very well phenomenon. And it's now, our experience indicated that in some areas we do have a groundwater with a salinity 60,000 ppm, which is double the seawater salinity. So we have to find a solution, and we have now in many areas in Abu Dhabi Emirate, which we call the deteriorated area, which we are not allowing drilling any groundwater well anymore or any development anymore in these areas. And we have now a lot of investment, a lot of projects which is ongoing in these areas, and we have to find a solution to protect the economic development in these areas. In some other areas, you will find that we are based or mainly using desalinated water for irrigation, especially if we know that 1 cubic meter is costing us, of desalinated water, costing us between 10 to 11 dirham as per RSB last recent reports. So this means that we are using a lot of investment for non-profitable sector, which is the agriculture sector and the forestry sector, and we are wasting a lot of desalinated water in these two sectors. So we have to find also a solution to overcome the problem of more investment every year in the desalination sector. And the environmental impact, of course. So we have two issues regarding the environmental. We are discharging tertiary treated wastewater to the Gulf, which have a lot of environmental impact due to the increase of nutrients and its impact on the water quality and the circulation of the water in South al-Musaffah and South al-Musaffah area. And we have, on the other hand, we are increasing our desalination plants, which we are using more energy. We have more emissions. We are also discharging more brine water to our marine ecosystem. So we have a lot of drivers that can push us to reuse the treated wastewater. The first sector that we can use the treated wastewater is the agriculture sector. And we studied and we formed a committee to study which crops that we can use. Most of the crops which we can use in Abu Dhabi is, or our recommendation as a technical committee, that we can use it at least for fooders. We have a lot of crops that is used, alfalfa, jet, rhodes grass, maize, which is used as a fooders for animals, which could be a potential source or a potential user for the treated wastewater, especially if it's tertiary in the future, which we are recommending now. The second is the increase in the amenity plantation, landscaping, recreational areas, and as have been mentioned, either inside the island of Abu Dhabi or outside the island of Abu Dhabi in the mainland around the island. one of the potential sources which have been studied carefully during the last few years is the aquifer recharge. Could we go to the aquifer recharge? And last year, I remember that Masdar and IAD, they form a joint committee, and we bring a consultant from Orange County because they have a good experience in recharging the aquifer with treated water, especially for protecting the groundwater aquifer from the seawater encroachment and from the seawater intrusion. But our indication in IAD and our results in IAD indicated that it is not visible to use the tertiary treated wastewater in Abu Dhabi for aquifer recharge. And this is because of many reasons. The first one, that aquifer recharge in Abu Dhabi is already here. This is a seawater intrusion width, and we have only 2 freshwater lenses exist in Abu Dhabi Emirate. These 2 lenses now is protected by a Amiri decree to protect them as a future emergency backup, natural backup, to be used in case of any emergency in the domestic water supply from the desalination plants. We find that the shoreline is very long, 380 kilometers far. So if we need to drill or to inject the treated wastewater along all this coast, we need a huge quantity. And only we have now at present something like 140 million cubic meter of unutilized tertiary treated wastewater. So this quantity is not enough to protect our aquifer from the sand, from the seawater intrusion, or to protect our aquifer in this area. And of course, it will cost a lot of capital investment, or need a lot of capital investment, because we have to make a pumping station, we have to make pipelines and injection wells. And we find that it's better, as mentioned by Malcolm previously, that better to use it for direct use. We can use it very simply for direct use, and it will be more efficient or more visible. The second sector which we can use the tertiary water is the forest. We have about 440 forests in Abu Dhabi Emirate. This is, of course, artificial forest. This is natural forest. It's a forested area. A forested area with native land, native species of plantation, which is from the environment of Abu Dhabi. And unfortunately, most of this 440 forests or artificial forests is using groundwater, and they are using now more than 350 million cubic meter every year. The problem is not only the groundwater issue, but also it is including a lot of capital works or infrastructure for distribution of this groundwater, and sometimes the groundwater well fields is very far from this area, which we have to transfer and to convey the water to this, from where we are producing to where we are using. The most important issue is the investment in this forest. Yes, it is environmental issue which we need in Abu Dhabi, because it is considered as a green belt to protect our infrastructure from the sand encroachments, roads, infrastructure like new settlements areas, the remote areas. It's also a natural habitat for wildlife animals, and have a lot of environmental issues, like it acts as a gene bank for the native species in the Emirates. But we are spending a huge money. 2-3 years back, the contract for maintaining this, for maintaining the infrastructure, including the tanks, irrigation systems, it was more than 3 billion a year. Dramatically, it has been reduced this year to meet something like less than 1 billion, but also it is a cost. 1 billion cost just because of the accumulation of the salts on the drippers, accumulation of the salts on the wells. We have to replace wells, we have to replace irrigation system tanks every year. And it is a huge activity. If we started to replace this ground brackish and sometimes hypersaline groundwater in some areas with treated wastewater, of course it contains more nutrients than groundwater, it is more fresher than groundwater, it will be beneficial, and even we can use less. So we started to introduce the reusing of treated wastewater for the forestry sector in Abu Dhabi Emirate. We have a lot of challenges. The first challenge is the limitation of the distribution network. We need to convey the water from where we are producing to where we are using. And unfortunately, we don't have enough infrastructure, pipes, pumping station, have been mentioned very detailed by Malcolm previously. to distribute and to convey from water from where we are producing to where is the demand center or where the demand center exists. So we need to invest more money, capital, for this capital work to increase our capacity in reusing tertiary water in the future. The second issue is the gap in the regulation. Unfortunately now, the water is collected, treated, discharged, or reused. The area for reuse still, there is a gap in the regulation, and there is no clear vision, as mentioned also by Malcolm, there is no clear vision where we have to use it, when we have to use it, what is the regulation, how we can enforce this regulation, what is the standard, what is the guidelines for reusing. Still there is a gap in this area. However, there is a regulation which is now enforced by RSB for the collection, treatment, and disposal, but there is no regulation, enough regulation for the end users, and also there is no water governance for the end user, who will use and what and when and how much. There is, of course, institutional and legal challenges, including the unclear policies, institutional conflicts between who will do what and when. Still, many during the last, and I think Malcolm can agree with me, during the last 2 or 3 years, we are, how many committees we did form to study this issue? How many meetings we did? How many reports we submit to GSIC? Many, actually. And it comes every time with a few more question, more clarification, when, why, how much it will cost, why, when, and this. The social acceptance and the reluctance. Still, there is some resistance from the end user, especially the owner of the farms. For the forest, there is no problem. For the recreational areas, there is no problem. But for the owner of the farm, still some concern about the health risk, especially the laborers working in these farms, about the production produced by these farms, the contamination of the soil, the contamination of groundwater in this area. However, I will give later on some examples that after some work with the end users, at the end they will accept it. We have, of course, environmental challenges. We are producing tertiary treated wastewater, which costs Emirates a huge amount of money. It's a very good quality of water to be reused, and it's not reused. It is the discharge to the Gulf. In the same, on the other hand, we are using groundwater. We are depleting our aquifer. We are deteriorating our aquifer system. Groundwater now, it's the most recent study which have been done by Environment Agency Abu Dhabi to evaluate the groundwater economics or to analyze the groundwater economics, indicating that 1 cubic meter of groundwater, because of the deterioration of aquifer and the problem of the infrastructure and wells and the pumping stations, these things, cost Abu Dhabi Emirates something between 5 to 7 dirham, which is nearly now, it becomes about the same like the cost of the desalination. The cost of desalination is between 10 to 11. And our cost for groundwater pumping and transferring, because it's very far and the oil field is very far from the areas which we need to use, costing us something like $7 dirham per cubic meter. And in the same hand, it is bad quality. It's brackish or even saline. And in some areas, as I mentioned, hyper saline water, which have a lot of impact on the irrigation infrastructure and the production of these crops. So we have to compare between these issues. So there is a lot of environmental impacts that also pressuring us to use the tertiary treated wastewater. Economic and technical challenges. We have a lot of economic and technical challenges, but fortunately, today I see what have been presented by Malcolm now to compare different projects and how much it will cost us for unit water or 1 cubic meter of water for each project, which give now more clear ideas about where we can start and where we can put this project in bending and reschedule them in the future. So we have more, better understand now for the economics. We started to think about reusing of the tertiary treated wastewater in 2009. And at that time, we do have challenges that we faced in IAD, that we have 2 or 3 well fields providing groundwater. One of them we called it Beda Ghanem, and the other we called it Al Hilaw, which we have these pipelines and the pipeline pumping about 6 million gallons a day to irrigate here something like 230 farms. The cost, we have about 220 wells in these areas. And the length of this one is 80 something, and this one is 160 kilometers far. And the leakage from these 2 pipelines is something like 40% leakage. So we are producing 10 million gallons a day, and we receive only here 6 million gallons. And these 2 pipelines are 20 years old or even more. Sometimes we spend 2-3 days just to search where is the leakage to just repair it. Because it's in the sandy dune area, it's not accessible pipeline, there is no route to access it, and we have a lot. The cost for operation and maintenance of these two wheel fields is something like 7.3 million dirham a year, just to produce 6 million gallons a day of water, and to irrigate. The quality here is brackish water. The salinity ranges between 4,000 to 6,000 ppm. And in the same time, we have this treatment plant here that we are discharging the treated wastewater here in this point, something like 14 kilometers far. Just if you implement a pipeline and provide them with tertiary treated wastewater, it's okay. And this was our proposal to the Executive Council or to the government at that time, and it's accepted. But when we started to do the survey and the implementation, we find a lot of resistance from the owner of the farms. No, we will not use or we will not replace groundwater with treated wastewater. And the answer is why? Because it's polluted water. Then we started to make a public acceptance survey, to make a survey for them. And we changed the terminology of wastewater to recycled water. And the acceptance increased from 40% to over more than 70%. Then we started with Abu Dhabi Food Control Authority to do a workshop for the end user, for the owner of these farms. We did something like 3-4 workshops, and we bring them to learn them that this is not a wastewater, this is not a raw wastewater, it is treated and it's tertiary treated. And at the end, with a lot of debate with even with the decision maker, we came to an idea to implement more advanced treatment plant, to use membranes. And also we came to a debate, should we use reverse osmosis or nanofiltration and ultrafiltration? If we will use reverse osmosis, first we will lose 25% as brine water or rejected water from the membranes, where we will discharge it. Second, we will lose the nutrients which exist in this water, and this is benefit to reuse the treated wastewater. And later on, we have to use fertilizer, additional fertilizers, and blah, blah, blah. So we find also a middle in between a solution, another solution, to use nanofiltration and ultrafiltration. Nanofiltration will not treat the salinity. It will contain, or it will keep the salinity as it is. It will not improve, remove the nutrients, but it will improve the quality of water in general. And we came to this idea and find that the cost reduction is something in the construction of this plant is something like 40% reduction. We already avoid the problem of the rejected water, very minimal quantity of the rejected water, which is used now for the irrigation of green fence in this area. And the water quality started, the acceptance of the public started to jump from 70% to more than 99%. Because we convinced them that this is now more advanced treated wastewater and they have no health risk, it have no impact on their products, it have no impact on their soil and their farms. And this gives us an idea that we can continue, as have been mentioned by Malcolm, not only in this small pilot project, but also on a larger scale. We are discharging 360,000 cubic meters a day, which is about more 140 million cubic meters of water, tertiary treated, good quality water a year. So we started with many projects which have been mentioned previously by Malcolm. The most important two, which we think that this is the most potential two, are Al Ain Road, which we can provide something like 22 forests, artificial forest area, and more than 2,500 farms with tertiary treated. And the second one is along Dubai Road, which we can convey something like 120, 140,000 cubic meters a day to many forests and about 2,000 farms also in this area. This is, I will give examples. We don't have a real examples about the cost of groundwater that we can compare to or calculate the return value of this project. But this is a real project here. We are using here to irrigate this area about 70 million gallons a day of desalinated water. 70 million gallons a day of desalinated water to irrigate native species or plantation, which is a salt-tolerant, drought-tolerant species, with a fresh water with a salinity less than 200 ppm. So we find that replacing this with treated wastewater, we can save at least with this 140,000 cubic meters a day, we can at least replace using 30 million gallons of desalinated water. The cost for the government, the last cost, not before even the increasing of tariff recently, was 1,000 gallon is for 10 dirham. Now it's doubled. I think, Matthew, it's doubled now, recently. So we are speaking about 1,000 gallon is equal to 20 dirham. If you multiply this cost, the return value for this infrastructure, which have been mentioned by Malcolm, which is 154 million dirham, the return value is 1 year or even less. 1 year or even less. So the return value for such a project is high. And we will say, yes, it seems for the first look that the capital investment is very high, but also if you look to the other hand, the return value for such a project is very high, and the environmental impact is very high. So our recommendation indicated that we have a lot of environmental sustainability pushing us to reuse treated wastewater. We have a lot of economic efficiency that pushing us to reuse the treated wastewater, and we have also the contribution for food security. So we have a lot of drivers indicating that it is visible and it is recommended to go ahead now with the reuse of tertiary treated wastewater in Abu Dhabi in the future, and we have to reach zero discharge and fully utilize all our production of tertiary water in the future. Thank you very much.
So, if I could ask all of the three speakers to come and take some seats at the front. We'll have 10, 15 minutes of Q&A. I've got a number of questions that people have forwarded through to me. If you've got any more questions, please use the iPads and send them through. I'll make sure I field them. So I'm going to stand up here and direct my questions across at you. And I'm going to start with you, Engineer Nasser Al-Nuaimi. So I spent the last 5 years being the commercial director for Thames Water. And in Thames Water, we're building a thing called a super sewer in London. And we thought we'd got troubles. And I feel greatly reassured having heard your stories. Because in Thames Water, we're building a tunnel under the River Thames. And you're having to do yours through a totally different environment. So my question to you is, if you were doing this project again, if you were starting the project again, knowing all that you know now, what would you do differently?
I would, probably Malcolm will disagree, but I would choose different routes. Different routes.
And, different route.
Yeah, and probably they always say it's a deep tunnel and it's really deep, but maybe this project was done actually, similar project was done in Singapore, but it's not as deep as this one. But we could use it differently by lowering, make it less deep, but we'll have 2 tunnels in that case.
And you'd have to pump, I assume.
Yeah, we'll have another.
So rather than all gravity, you'd have maybe kept it high, nearer the surface.
Yeah, but this is, people will fight with me, especially Malcolm, and the guys will fight with me because they really they think that, and it is the right one, the right solution for the moment. It's really going to help us for the future growth.
Excellent. So I can't resist. I'm going to flick over to Malcolm to see if you've got any comment in terms of a different route.
I never fight with NASA. No, I mean, a lot of people do discuss the single lift philosophy against the double lift philosophy. Yep. Getting down to the deeper end of the tunnel, it becomes more difficult to connect to for future connections. So you may have to bring sewage in to get to a
higher
depth
up,
that you can connect to before you go back out again. So it all depends on where the development will happen in the future, whether the development will move out towards the treatment plants or not. But I think the calculations back in 2007, 6, 7, 8 all looked into, there was a massive feasibility study done at the time, and the decision was made when we were with ADWA at the time to go with the single lift, and that's how we ended up. So we all agree with that solution.
Excellent. So I guess what I'm hearing is lots of the very big brains people did the technical review, and there's always challenges. I'm going to come back to NASA. So one of the big challenges you have when you drill any tunnel is you don't know what you're going to hit. You're going to drill a tunnel and you're going to hit a surprise somewhere. You hit something in the rock that you didn't anticipate is the typical challenge. Have you had any of those sorts of challenges? Any moments where the phone's rung and someone said, we've got a problem?
Yeah, see, the tunnel, we used 8 large TBM machines. This is really, I would say, it's a factory, moving factory underneath the ground. Nobody can feel it. It's really equipped with sonar, kind of sonar system, where we detect 100 meters away, like what is really in front of the TBMs, so it can control itself. You
can steer it. You can drive around difficult things.
Around, or maybe push it harder or something. Okay. So one of the difficulties we face by Mafraq area, that we have, you all know that we have mangrove, Flamingo Lake.
Okay.
We have the Flamingo Lake. Just I don't know if we can go back to my slides. I don't know what we can show the Flamingo Lake.
We've got to wade through Malcolm's 400 slides if we do that.
See,
I'll see if I can get there.
The Wahba Lake.
It is a wetland area that is already fed by treated wastewater.
Yeah, well, it used to be, but now it's really water.
Stay with me. We're almost there now, I think.
Oh, you need to go all the way back.
Yeah, it's frozen on me.
It's okay. One of the map I can just. Oh no, it doesn't show it.
I've got to go through these ones. It's not moving quick enough.
Anyway, so if you stop one of the slides, I can just.
Which one do you want me to stop at?
I know.
I think
it's too busy. Malcolm's slide is too busy.
We're still on Malcolm's. And they've got to load up the picture before it'll let me go forward. So let's give this another minute.
Okay, take your time.
Come on.
Sorry, I mentioned.
Oh, that's not good. What's happened now? I've broken it. Oh, you're doing it from them. Excellent.
Okay. This mangrove lake where the machine was moving forward, and the machine detect that there is, water in front of it. So it was really at that time. Oh, okay. It's the map actually. Sorry. Yeah. Can I point you? Oh, no. Yeah, okay. It's this one. This is the lake.
Okay, all right. So you had to divert around there, did you?
So one of our TBMs, which was the TBM number 4. TBM number 4 was lower than this area, and it has to travel crossing the sorry, I don't know what I'm saying. Crossing actually Flamingo Lake. This is the Flamingo Lake going to Workshop 7. So this is 5 kilometers. So the moment that the machine reached here, it was really, are we facing water? So are we going to stop the project? So it was difficult for us. But we decided to let the machine move on with the pressure that it automatically can adjust.
And you just crossed your fingers and hoped.
Yeah, that's what we did, and we pray to God that nothing happened.
All the best engineering projects are like that.
Yeah, I don't think Malcolm knows the story, but...
No, I don't know the story.
Okay, but we crossed it, and there was no water at all.
Excellent.
Yeah, it was just, what you call it, just a small amount of water. So the machine is designed just to force, to excavate against any material it's forced.
So thank you for sharing, because it's those little stories that make a scheme like this, because it's very easy to sit back and look at the schemes. The engineers will do what they need to do. But you know what the reality is? Yeah. That there are scary moments. There's unknowns. There are moments where you go, my God, we're going under a lake. This thing's going to collapse. And actually, no matter how much engineering's done, you never know for certain. Thank you for that. Malcolm, so I've got lots of questions for you, but I'll only pick a couple. Your project program, those slides of all of the things, they're so ambitious. They're so ambitious in terms of the scale, in terms of the amount of investment, in terms of the construction program. It's eye-wateringly ambitious. Is it doable? Is it keeping you awake at night?
No. It's definitely doable. I mean, to put pipelines in the ground is a very doable thing. It's a case of prioritizing where to spend the money. There's extreme pressure on us, even every year, in terms of how much we can spend in capital projects. This year, even more so because of the oil price. We're facing big pressure on our capital programs. So it's, what I showed was a large number of projects which could happen. I'm not saying we've asked for all of them, we've asked for money for all of them to go ahead. The city schemes will amount to around 1.2 billion dirhams, the regional schemes more. So it's really to demonstrate that we, as ADSSC, have looked at the plans, have looked at the technical requirements for the pipe size, the pump sizes, the reservoir sizes, what needs to be done to get our water to the areas that have asked for it. So I'm not saying we want to do them all today or we'll do them all tomorrow. Obviously there would be a staged and stepped progress on all the projects as and when demands come along.
So do you think this is a strategic picture for the next 10 years or the next 50 years or the next 200 years?
It really depends, because a lot of the developers say we wanted the water 4 years ago. There's no development. Yeah. A lot of the people will say, you know, Reem Island I have sympathy for. They have built, they are building, they are going ahead, and I can't get them recycled water. However, with the tunnel wastewater connection, which is coming on from Reem Island to the main island to connect to Nasser's tunnel, we've included a return recycled water pipe in there for them. So we will have a recycled water pipe going across the water, but we will be missing infrastructure on this side, and they will be missing infrastructure on their side. So, you know, Yas Island demanded a huge quantity 5 years ago. Nothing's happened. Khalifa A from the municipality, huge quantity demand. Nothing has happened. Hydro Village, Hydro City. And they all said, we want the water tomorrow. And we said, okay, well, we've built this ring main, we can feed you all. Yep. Nothing's coming from it. So they haven't been able to turn their demand into consumption as quickly as we've been able to deliver transmission infrastructure. So once they get their act together, we will try to feed them.
It is a definite chicken and egg, isn't it?
Yeah.
If you didn't have it there, no one could use it anyway. So that it requires baby steps and brave baby steps. Yeah. So a question that came from the audience was specifically for you around, so how much water is non-recyclable? Out of all of it that's there, is there a fraction of any water that you go, actually, we couldn't have recycled that even if we wanted to?
No, well, we recycle everything. 100% of all wastewater that we receive, we turn into a very high quality product. 1 or 2 days of the month we will have some issues with the chlorine or the filter beds, and there will be 1 or 2 parameters that may fall outside of the quality requirements. We have 1 or 2 customers who want to give us exceedingly strong effluent from their premises, which we have to reject because they're not meeting the trade effluent requirements. We have had some issues in the past with zinc, but most of the issues with zinc end up into the biosolid stream. So really, for the recycled water, we don't have any real challenges in terms of treating the sewage. Our sewage that we receive is a very municipal sewage. Yep. Although there are areas or some customers who want to discharge some extremely strong effluent to us, in general, as a city, compared with other larger and more industrialized cities, we have a very municipal, a very residential type sewage. It's quite a weak sewage. Yeah.
Yeah. Okay, so, and the big takeaway I took from your presentation was that essentially, you know, if we want to do 100%, or we want to increase the amount of reuse, the big thing that's got to happen is a single entity, a single guiding mind that sits over all the reuse assets. So, and you highlighted a little bit the stresses and strains around that. Just to help me with the timelines associated with that.
Timelines for that I can't answer. But what really needs, whether it's a single entity, setting up a new company or setting up new entities is difficult, but things can happen very quickly in Abu Dhabi. What needs to be possibly put together is what has been suggested in the past by Environment Agency studies, which would be a water council, which would have on board ADWIA, the regulators, the Environment Agency, the UPC, ADSSC, ADDC, Transco, etc., and have permanent membership when that entity could meet on a regular, almost permanent basis, and you would have permanent members in that council discussing technical issues, policy issues, strategy issues, and that's something that could be set up very quickly. I think most of the entities know the individuals who would be best placed to go onto that organisation, and we could just take.
You could name on your. You could name them now. Specific people.
Yeah, I think so. And I think really, but it's for us to then educate the decision makers and the higher authorities, because they're the people who write the checks for the investment. And right now we are lobbying the higher authorities to try to give them the confidence to move ahead with some of these projects so that we can stop dumping water in the Masafa Channel, which is why I said in my presentation, let's do the Dubai scheme, let's do the Al Khatim scheme, and then use the remaining water for smaller city schemes.
Thank you.
In addition to Malcolm, the committee that he mentioned, all the authorities, they announced last year in the same summit, in the International Water Summit, last year 2014, it's the Water Committee. So it was announced in the opening of last year Water Summit. So this, for the full year,
it's all coming together.
Yeah, it's all come together, one mind, one thinking, just one target.
Brilliant. Yeah. Thank you for that. Dr. Dawood, so your presentation struck a chord with the audience. I have lots of questions here. There's no way, I'm afraid, I'm not going to be able to raise every one of the questions that were raised. So let's start with, is there a code within Abu Dhabi that controls the recycling of wastewater, of TSE into agriculture?
We do have a code which has been produced by RSP in 2010. I think we have our colleagues Matthew here working with that. So, but it needs some more update. And I think now Abu Dhabi Food Control Authority have been appointed by the government to work with FAO to develop more advanced standards or guidelines for reusing treated wastewater, especially in the agriculture sector. So most recently we started to have a look on this issue, and now Abu Dhabi Food Control Authority appointed to go ahead and produce more advanced and comprehensive guidelines and standards.
Okay. Now, I assume is there practice out in other countries that you can follow and adopt?
Yes, there is, of course, and there is even practice in many countries. Even recently, some colleagues from our Abu Dhabi Food Control Authorities, they did visit Saudi Arabia because they have a long experience in this field. In Egypt, we do have the same experience, and in many countries here in the region, they started to use treated wastewater for a long time. So we do have some experience here in the countries, in the region at least.
Okay. Yeah. Now, I'm going to ask you the question, but I'm aware that Matthew's in the audience, so we may be able to draw him in as well. But another question that came out was, what's the role of the RSB in setting and shaping the TSE strategy?
I think Matthew can better answer this question better than me.
Sorry, Matthew, to put you on the spot.
We sit on the committee.
There's a microphone there. Do you want to just take that?
Thanks. My name is Matthew Griffiths and I work for the Regulation and Supervision in Abu Dhabi. We sit on the committee, so we've been working on this for a number of years and fully support the concept of one entity having an overarching view and position. And I touched on it, if anyone was in a panel session I did earlier on general policy and the importance of aligning policies, because what you've got is a sector that's reasonably well regulated, trying to give water to a range of end users, all regulated by different agencies with different needs. So what we recognise, and Malcolm used the word confidence, and I think it's exactly that. All these different customers need confidence in the product to use it, whether it's agriculture, industrial recycling, whether we get it closer to people and use it in toilet flushing. There's all sorts of options out there, but it's building the confidence. And what we did was develop a regulatory framework that took it to those doors, and we believe the standards we've set are actually fine to take it inside those doors as well. But it needs a bit of work to adopt it throughout all those different endpoints. But yeah, everyone's pretty much on board with the reuse. Everyone's on board with the need for one entity, and it's just making it happen.
Okay, thank you, Matthew. That's very good.
Actually, just building on what have been mentioned by Matthew, there was two proposals which have been submitted from the higher Committee for Water and Agriculture in Abu Dhabi. And because I'm acting as a secretariat for this committee, I draft these two proposals to the government. The first one was to establish, as has been mentioned by Malcolm, the Abu Dhabi Water Council. And unfortunately, we have a lot of debates with the government now since the last 2 years. Should we go to this Abu Dhabi Water Council or establish a new entity or something like this? The other one was a proposal submitted to the higher committee by our colleagues in RSB to establish a company, a distribution company for non-potable water use, which also unfortunately have been rejected by the higher committee. And instead they offer to do a separate department under the Abu Dhabi Distribution Company and a distribution company for distributing the non-potable water. But also this proposal, unfortunately, it's debatable now with the government.
Okay, my last question to you, again, it's one that's come from the audience, is the amount of water that's required for landscaping more or less than the amount of wastewater that's coming from the municipal sector?
More.
So for landscaping, it's more.
The demand from, I mean, I have a table in my office which will show you demand in 5 years up to 1 million cubic meters per day.
But again, this is
much
theoretical
more.
demand.
But it's theoretical demand.
Exactly.
It's the same point you just made around people say they want it, but once you build it, are they going to take it? Yeah.
But
because we are receiving the same request as mentioned by Malcolm for the since 5 years, and nothing happened.
But
and we are continuing discharging the tertiary treated wastewater to the Gulf.
The municipality can only consume, and they're the much biggest consumption. They're really consuming it, which is great. They're only consuming 250,000 cube per day. But if you go to, because developers tend to be very ambitious and very dreamy, and they like to see beautiful grassy developments, which is all very nice. But they make decisions on investment very, very in a very short-term view, and they switch off a lot quicker than they switch on. So I can show theoretical demand with enormous figures, but realistically, are you going to take the water from me? I doubt it. I'm going to go somewhere else, which is what I'm looking at the moment. I'm having to go outside the city with regional schemes because the developers haven't turned their theoretical demand into actual, I want to consume this now.
Excellent, thank you for that. Now, just before I make it...
Just also another, just a few, but not only this, but also now there is Istidama code, which have been now developed by UPC, Urban Planning Council of Abu Dhabi. And this Urban Planning Council Istidama manual is looking for to minimize the green landscaping and to replace it with hard landscaping and engineering activities within the landscaping, which should, as their expectation, should reduce the water consumption in the landscaping in Abu Dhabi Emirate to be less than 40% or minimize it by 40–60%. This means that we will have additional surplus of treated wastewater which is not used in the future. So this is also put us under pressure that, or drivers that we should use the tertiary treated water somewhere else outside the island for regional projects which have been mentioned by Malcolm.
Before I make a closing comment, I'm just going to scan across the audience in case there's anyone who's got a burning question they want to raise. We do have a microphone. No. So, gentlemen, I'd like to thank you. I'd like to thank you for making that so interesting, because it is fascinating to hear these projects. And just to be a little bit impassioned for a second here, tomorrow I'm giving a talk around lessons we've learned from the last 500 years in the water sector. And in researching that talk, it became apparent to me that we all stand on the shoulders of giants who did projects just like the ones you're doing today. We stand on the shoulders of the giants who pushed these projects through, who got them financed, who overcame the challenges and built the infrastructure upon which we live and breathe now. So the tunnel that you're building and the TSE and water reuse infrastructure that's being built now, yes, there's a frustration that people aren't using it, but you know what? If we project forward 2, 3, 5, 10 generations, people will look back. Sadly, I suspect they won't remember your names. Sadly, I suspect those will get lost in the mist of time. But actually, you are making a change for the good, and I thank you for that. And if we could thank the speakers in the usual way.